everyone, today I'm going to be doing this Pure Math 2 paper with you. So it is the February-March 2023 paper. The code is 22 and this is just Pure Math 2. Alright, let's dive right into it. So our first question, they say find the exact value of the integral 2 tan squared half x dx. Okay, so the first thing that I want you to know with integration is you need to know what you can and what you cannot integrate. So I'd like to know, I've just got a little list and it helps to take a look at your MF19. When it comes to trig functions, you can integrate sine or cos or sec squared. Okay, so it's important to note you cannot integrate something like sine squared x or cos squared x. You would need to change those into a double angle. So you'd use the cos double angle before you can integrate something like that. Now this question is interesting because it gives us a tan squared. So we can't do a tan squared either. So what we need to do is we need to change this trig expression into something that we can integrate. So I'm going to jump into my trig section over here. So just so you know, I've also taken little snippets from your MF19. So it's good to always have your MF19 next to you to help you work from. But it's also very useful to know what trig identities there are so that you can immediately spot what you need to do if you were in an exam. Okay, so what we've got here, we know that there's a relationship between tan squared and sec squared. So if I can change this tan squared into a sec squared, then I know that I will be able to integrate it. Okay, so that is going to be my strategy. So the first step is to know what you are able to integrate and what you aren't. And then if you can change what you aren't able into what you are able, that's the first step. So I'm going to just rewrite my definite integral. And here I know that tan squared theta, if I just look at this identity, tan squared theta is going to be equal to sec squared theta minus 1. So this is sec squared, and instead of theta, I've got a half x minus 1. All of that's in a big bracket, okay, because the 2 is now going to be related to both of those terms. So I'm just going to simplify this. That's going to be 2 sec squared half x minus 2, and everything is dx. All right, so now I can integrate sec squared, and I can integrate 2. So we've changed it into something that we are able to do. I'm going to immediately just integrate. So sec squared goes to tan x. So I'm going to keep my coefficients. I'm going to go to tan half x. When I'm using the chain rule, because I can see here it's not just tan x, it's tan a half x. So I also need to divide by the coefficient of x. And then I can say minus 2x. That's going to give me the integral. This is pi over 2 and 0. All right, so immediately I can just plug in. I actually might want to first simplify this here. So 2 divided by a half becomes 4, tan a half, and then this becomes pi over 2. Okay, minus, if I plug 0 into tan, it's going to give me 0, and so is the other term. So I'm not going to bother writing them down, but you do need to make sure that you check those terms, because, for example, if I had to work out cos of 0, that does not equal 0. Okay, so you must be very familiar with your trig functions and what they actually look like if you want to take shortcuts. Okay, tan of pi over 4 is just 1. So I'll write it for now, but you don't really need to write that. So my final answer is 4 minus pi, and I should have pointed out in the beginning, but they asked for the exact value. Okay, so we're not going to be looking at decimals or significant figures. We're going to leave it exactly like this, 4 minus pi. Right, jumping right into our next question, solve the equation. So here we have trig again. They say solve the equation, so we're not proving an identity, but here we've got a full equation and we can use both sides. On the one side we've got some tan, and on the other side we've got cot. So we can't really do anything simpler for now, so we are going to expand this. So if we use our tan compound angle, I can expand this. That's the only thing I can really do on one side. And then cot, we know that cot is basically the inverse of sine, so it's going to be equal to cos over sine, or it could also be equal to 1 over tan theta. We'll have to see which one we find more useful. Let me just show you what I wrote there. So these are identities that aren't on your MF19 that you just need to be familiar with how to use them. Okay. All right, let's jump into this. So I'm first going to expand my tan. That is going to give me tan of theta minus tan 60, and then 1 plus tan theta tan 60. Okay, now my tan of 60, you can just do that on a calculator, but that answer is going to be √3. So I'm going to have tan theta minus √3 of 1 plus √3 tan theta. Okay, so I've just expanded the left-hand side at the moment. I could have done that all in one sum, but I just did it separately. There's no need to do it separately. And I think because I've just got tans here, what I'm going to do is I'm going to change my cot into, well, my 3 cot theta, I'm going to change it into 1 over tan theta. Okay, just because I've got tans on the one side, I'm just going to work with tan on the other side. If I can get a single expression only with tan, then I can solve it. So instead of going into cos over sine, because then I'm going to have coses and sines and tans, let's just see if we can solve this by sticking to tan. All right, so I'm now kind of going to cross multiply. So this side gets multiplied by tan theta, and then this side is going to be multiplied by 1 plus √3 tan theta. You don't need to write in the purple bits that I just wrote. I just want to show you my thinking. So this is going to be tan squared theta minus √3 tan theta. That's equal to 3. Okay, and what you can see is this is going to start forming a quadratic in tan. So I'm going to keep my tan squared theta, then I've got minus √3 plus 3 √3. It's going to give me minus 4 √3 tan theta minus 3 is equal to 0. And here you can see we've got a quadratic in tan. So if we were just to take a look at our A, B, and C value, I'll just write them down. Our A is equal to 1, our B is equal to minus 4 over √3, and our C is equal to minus 3. I think the easiest way to solve this is going to be using a quadratic equation. Okay, and that is going to give us an answer. Okay, if we plug that into our quadratic formula, we're going to get tan theta is equal to minus 0.4089, or tan theta is equal to 7.3371. Okay, you want to make sure your calculator is in degrees, because we're also going to be looking at degrees over here. All right, whenever we're working out these equations, we also now want to find all the answers within the domain. So we're going from negative 90 degrees to positive 90 degrees. So I like to always just draw on the side, what does my function look like? So in this case, it's tan, and we're going between 90 and minus 90. All right. And we're going to be looking at two values. The one is minus 0.4 or something like that. It's probably going to be much closer to my axes. And then my other one is 7.33. So this is not at, drawn to scale. Let me just move that one up a bit. So this is going to be minus 0.4. So I expect to get one answer for each of these questions. Okay, if I go and look at my inverse tan function, I do get my one answer, which is negative 22.2 degrees, and then my other one is 82.2 degrees. Okay, we do not need to look for any other answers within this domain because tan graph repeats itself every 180 degrees. So whether I add or subtract 180 degrees, it's going to take me outside of the domain. So those are my two final answers. All right, let's just jump right into the next question. So here we're looking at polynomials, polynomial division, and the remainder factor theorem. So it says a polynomial is defined by, and then it's got some a's and some b's in the polynomial. A's and b's are constant. It is given that when x plus 2 is a factor, that x plus 2 is a factor. Okay, so if I plug minus 2 into my equation, I know that my final answer should be 0 because it's a factor. So let's do that. Okay, so, and I'm just going to simplify this. I haven't even read the rest of the question yet. Maybe I must quickly do that. So the remainder is 35 when it's divided by x minus 3. Find the values of a and b. Okay, so this is a very typical question. The trick is that if it's a factor, it's going to be equal to 0. And if there's a remainder, then we need to equate it to the remainder. And then we're going to use simultaneous equations between the two. Okay, so I have already set this one up. Be careful with your positive and negative signs. This one is 4a. Okay. So minus 8 minus 4 minus 2 is minus 14a plus b. So b is equal to 14a. Right, and if we take a look at the second one, I'm going to plug in 3. So you must always plug in kind of the opposite sign. The way that I like to do that, I make whatever my factor is equal to 0. And then I need to plug in that value. Okay, so sometimes you don't have x plus 2, but it might be 3x plus 2. Okay, so that's why I just make it equal to 0. Now if I plug in a 3, I've got a 3 to the power of 3 and here it is equal to a remainder. Okay, so don't forget the remainder. I also like to double check that I do put my remainder in because I have gotten it before. Right, so that's 27a minus 9a 5. Okay. So I'm going to make a b the subject of my formula because now I can do simultaneous equations between 1 and 2. So I know that 14a is equal to 35 minus 21a. Okay, so if I add up those two, I'm going to get 35a is equal to 35. So that means my a must be equal to 1. And if I then plug my a into any of my equations, I'm just going to plug it into the easier one, then I know that b is 14. All right, so that's a very typical remainder factor theorem question. Make sure that you're plugging in the right thing, equating it to the right thing, and then doing simultaneous equations. All right, part B, they say hence factorize and show that the polynomial has exactly one root. All right, so we're going to factorize. Hence means we're going to use our answer from before. Okay, so how are we going to do that? First of all, I think the best thing to do is actually rewrite the polynomial with the correct values. So we've got, it's going to be ax cubed, so a is just 1, minus x squared, okay, plus x plus 14. Okay, now if we're going to factorize this, the first thing that we need to do is use the factor that they gave us. So they told us that x plus 2 is a factor. Okay, so I know that this thing is divisible by x plus 2. It's not going to have any remainder. So you can do polynomial division now. It is possible to do this without polynomial division, but sometimes polynomial division is just quicker. The other way that you do it is through inspection. Okay, but it can sometimes be a bit more tricky. So I'm just going to do polynomial division, and then we'll see what is left over when this thing has been divided. Right, so I've got my x cubed divided by x. It's just x squared. Then I'm going to multiply both my terms through and write them underneath here. So that's x cubed plus 2x squared. So divide, multiply, subtract. Okay, so I'm going to now subtract these terms. So I've got 1 minus 1 is 0. And then I've got minus 1 minus 2. So minus 3x squared. Okay, and then I'm going to bring down my next term. This should definitely remind you of long division in primary school. Okay, so bring down the next term, and now we're going to divide again. So I'm going to divide. When you divide, you only divide the first term by the first term. Okay, so I'm dividing the first one by the first term. That's going to give me minus 3x. Now multiplying both terms. Divide, multiply, subtract. So 1 minus minus 6 is 1 plus 6. And then bring down. Okay, then we're dividing again. So in this case, I'm going to have 7. Now I'm multiplying 7x plus 14. That's exactly what we want it to look like, so that there's no remainder. Okay, so 7x plus 14 minus 7x plus 14 gives us no remainder. All right, so if you think of this backwards, we now have x squared minus 3x plus 7 is multiplied by x plus 2. I know that if I multiply those things back again, I'm going to get to my polynomial. Okay, so the important thing now is to see, can this be factorized any further? Okay, so remember, when you've got a polynomial, if this is equal to 0, okay, it means that each bracket can be equated to 0. And for every answer that I get, I'm going to have a root. So they are saying, show that the equation has exactly one real root. Okay, so we already know that here, x plus 2 is equal to 0, so x must be equal to minus 2. We already know that that is a root. So how do we prove that there's no roots to this quadratic? Okay, now you might need to dig into your pure math 1 knowledge here. If you remember, if you can prove that the discriminant is less than 0, then it's going to have no roots. Okay, so that's what we want to try and prove. So I'm going to say b squared minus 4ac, that's my discriminant. It's 4 times 1 times 7. It's going to give me 9 minus 28. And you can see that that's going to be a negative answer. Okay, oh, 29. Okay, negative 19. Therefore, no real solutions. Therefore, x equal to minus 2 is the only root. So that's kind of what I would write for something like this. So we know that the one part of our quadratic is not going to have any solutions, and the other part gives us one answer, so the final number of answers is only one. So remember that an answer is a root. Okay. Right, let's move on. Just out of interest, so you should be familiar with this kind of thing, but just out of interest, that our quadratic, if we just work that out, is basically going to be a quadratic that lies above the x-axis. So there's not going to have any, it's not going to cross anywhere. Okay. It's nice to put the picture together as you do these questions. All right, let's jump right into our next question. So our next question is all about mods. It is typical that they ask you to sketch a diagram, well, sketch a picture, although it's not always that they do that. So they say, on the same set of axes, sketch the graph of that and that. Okay, first of all, I want you to notice that one of them is a mod equation, and the other one is just a straight line. Okay, sometimes I have got it confused before, where I draw both of them as a mod. Okay, that is definitely not correct. So just take note, one of them is a mod, one of them is a straight line. Okay, and the easiest way that I draw my mods is I like to find where is my new x-axis. So you can make what's inside the bracket equal to 0. Okay, and that is 11 over 2. Just going to give me 1, 2, 3, 4, 5. So it's somewhere 5.5. So that's my new x-axis. Okay, and then the other thing that I like to do is I like to make x equal to 0. And that's going to give us where it's going to cross the y-axis, which if you take the mod of -11, it's just going to give us 11. Okay. 5.5 and 11, this is not exactly drawn to scale at all. But those are little calculations I would do on the side, and then you just got to make the V look like have the same gradient. Okay, I need to be careful now because my scale is quite out, but it should be fine if I use the same scale for my straight line. My straight line, I know that my intercept is at -3, so let's just say that was 5, 10, 11. So that's about 5. So 3 is going to be somewhere around there. And then it has a gradient of 3. So it's going up 3 and across 1. Okay, you can also just find where are the x and y intercepts. I think that's also a very nice way of drawing a straight line. It's actually just finding the x and y intercepts. Okay, hopefully if you have a ruler, you'll be able to do this in one go. What is important is that you draw your gradients in a way that you can see how many times is the mod and the straight line going to intercept. So what you basically want to see is the gradient of this one is 3 and the gradient of this one is flatter. So those two lines there that I've highlighted are never going to touch each other. Okay, if my straight line, let's just see how I can do this. If my straight line had a flatter gradient, then it is possible that it also intersects, this line later on. Okay, so that's just the principle that I want to show you, and we'll see what the questions are that follow, but that you generally need to get the gradients of these graphs correct and show where they intercept on the x and y axes. That would be the best option. What they say here is solve the inequality. Okay, so I want to now relate this to my graph. It's really cool if you can actually understand how these things relate. Okay, so where is the mod less than the straight line? Okay, so if I'm looking at my equation, my mod, can you see over here, my mod is higher up than my straight line. All of those values. So my mod is greater than the straight line. They are asking me, where's my mod less than the straight line? So can you see if I cross that point there, my straight line is now going to be higher. It's always going to be higher than my mod. It's going to have a greater y value. Okay, so I know if I can find this point of intersection here, all the values greater than that, my mod is always going to be underneath my straight line. Okay, so that's just an interesting way to do it. I find it, if you understand the way that the graphs work, then it makes the calculation quite simple. Okay, so because I can understand my graph, I can just write down my mod. They are using the negative arm of the mod. Okay, so this is the positive arm going to the right, and that's the negative arm going to the left. So where they intersect, I can see it's the negative arm plus the straight line. So that is minus 2x. Let me just rather write it like this. I'm going to take the negative. Okay, and that's equal to my 3x minus 3. So basically minus 2x plus 11. So 3x minus 3. So I'm going to say x minus 11. Um, 3x. So that becomes minus 5x. And 14. Okay, so these cross at, sorry, that's also negative over there. These cross at 14 over 5. So I know that x must be greater than 14 over 5. Because I know that my answer is this point and everything more than that. Okay, now I don't know if I've maybe been a little bit confusing. So if you understand the graphs and you kind of know what you're doing with the algebra, this is a nice way to do it. Okay, if you don't really know what you're doing with the graphs, let's just see. The default would be to square both sides. Okay, so that's going to give us 4x squared minus 44x. Okay, 9x squared. Let's just move this up a bit. Okay, you see, I find this quite a lot more work. That's why I quite enjoy the other method. Okay, so I'm going to take my x's. Oh, let's just take them all to the left. We'll work with negative x for now. So minus 18 plus 18 becomes that becomes negative 44. Sorry, negative 44 plus 18 becomes minus 26x. And then 121 minus 9, 112. That's less than 0. Okay, you can immediately see why I don't like this. X. Okay, if I divide through by 0, I need to remember to flip my sign around. Okay, and now I am going to get two answers, but I need to know that one of them is not valid. Okay. Okay, so if I factorize this thing, you can also use your quadratic equation. You can have a 5 and a 1 and a 14 and an 8. Okay, so this is going to be 5x minus 14 and x plus 8, which is greater than 0. Okay, so when you're solving an inequality, going back to pure math 1, I know I've got a negative 8 and then I've got a 14 over 5, and I want to know where's my function higher than that. Okay, so x must be less than negative 8 or x must be greater than 14 over 5. Okay, but the problem now is that our one answer, where does that other answer come from? It basically comes from if this line was extended further down, those two would meet at negative 8. So that's where the answer is coming from, but that's actually not the way that this graph works. So this answer is not valid, okay? It's only the one answer, x is greater than 14 over 5. So I personally think, squaring both sides, you'll have a good chance of getting to an answer, but then knowing which one's valid and which one's not, you still need to understand how to read off the graph and see where's the straight line higher than the mod. So it's definitely something I would practice. I personally think it's much easier to use the first step, but you then need to know which side of your mod graph you're working on. So you can practice, both of them are going to take practice. I think the first method is just a little bit less work. Okay. Now, here's an interesting question. They say, find the smallest integer n satisfying this inequality. Okay, so this is interesting because there is a similarity between that and something up here. So we've already solved this inequality. 2x minus 11 is less than 3x minus 3. We know that the answer to this is that x is greater than 14 over 5. Okay, so can you see that this is pretty similar? If I take a look, I've got my 2 and my 2, and I've got my minus 11 and my minus 11, and those are in a mod. And then I've got a 3 and a 3 and a minus 3 and a minus 3. So the conclusion here, or what is similar, is x is now equal to ln n. Okay, so that if x was equal to ln n, then these equations would be the same. All right, so to solve this, I basically know that ln n is now greater than 14 over 5. Okay, and they say find the smallest integer to satisfy this equation. Okay, so we just need to find out what is n. How do you solve a ln equation like this? If I've got ln on the one side, I can e it. So I raise it 14 over 5. Okay, my e and my ln are kind of inverse of each other. Okay, so now I've got n must be greater than e to the power of 14 over 5. So we just got to work out what is e to the power of 14 over 5. Okay. Okay, e to the power of 14 over 5. So n must now be greater than, that is 16.446. Okay, so they want an integer. What's the smallest integer to satisfy this? So we know that it must be greater than 16. The next integer greater than 16 is 17. Okay. All right, so all of these papers full of lots of tricks. The more you do, the easier they become, but definitely worth practicing. Okay, I'm going to jump right into the next question. Here it says, it is given that. And now we've got an integral. We can see it's a definite integral. Interesting thing is it's a 1 and an a. So it's not numbers, but there's a variable that you need to plug in. Okay. But it's given us an answer. They've already given us the answer to this integral. Okay. And then they say that a is a constant greater than 1. Okay, so that might come into play a little bit later. A is greater than 1. For example, if there's two answers, we know that the correct one is the one that's greater than 1. And here they want us to show a specific formula. And what we see is you've got an a on both sides. So we know that we are busy with numerical solutions. Also called numerical analysis. All right, so it's good to know what topic you're busy with. This is, I think, is the 6th topic in your syllabus. Okay, so question is, can we integrate this, or do we need to change anything? They are two separate terms, so we can integrate them separately, and they both look integratable, if I can put it that way. We're going to be using this format over here, so 1 over x. The integral of 1 over x is ln x. Okay, but you need to remember that you've got a composite function over here, and you've got a coefficient to both of your functions. All right, so if I were to integrate this, I'm actually just going to, I'll just write down the question. You do not need to rewrite the question. this, by the way, but I'll do this just for the sake of showing you that you can integrate them separately. You just need to do you need to write dx for each of them if you are going to separate it. Okay. So the integral, I'm going to keep my coefficient. I'm going to integrate my function, and then because we are doing the reverse chain rule, I need to divide by the coefficient of x. Same goes here. I've got my coefficient, and then I don't have a composite function, so I don't need to divide by anything. Now we're going between 1 and a. Right, so I just do exactly what I normally do with integration. I plug in my upper bound, and then I plug in my lower bound. My 4 and my 2, that just becomes 2 ln, and then this is 1 plus 2a plus 3 ln a minus, okay, I've sort of made a lot less space for myself here because of my formula sheet, but you would do that in one line, minus, maybe I can actually just, we don't need this right now, so I'm just going to write over it over here. Okay, so minus big bracket 2 ln 3 ln 1, okay? And if we just look at each of these separately, so eventually we want to prove this whole thing. Okay, so we know that this entire thing is equal to ln 10. Okay, so I'm just going to see if I can simplify any of this for now. 1 plus 2a. We know that a is a positive integer, so we don't even need our mod signs anymore because it is going to be positive. 2 ln 3, and then that negative also goes to that term. Ln of 1. Okay. Okay, ln of 1 is 0. So I've got 2 ln a minus 2 ln 3. And now we know that that whole integral is equal to ln 10. Okay, now we need to rearrange this. So we're not necessarily solving anything here. We need to rearrange this. So I just want to look at what is the format of this. What I look for is I can see that this is the cube root. All right, so if I were to kind of reverse this, I know that I would end up with a to the power of 3. Okay, a to the power of 3. If I take a look at this, I don't yet have an a to the power of 3, but if I take up my coefficients, I can see I'm going to end up with an a to the power of 3 over here. Okay, and that is probably what I'm going to make the subject of my formula. So that's how I like to do these questions. I just like to take a look at what am I aiming for and how am I going to get to it. Okay, so let's just go. For now, I'm going to remove my coefficients by taking them up, and that's just log laws. 3 minus, I'm just going to leave that as a minus, ln 3 to the power of 2. So the mathematics will work itself out. If you were to take up a minus 2 and say plus, will work itself out. But for now, I'm just going to do this. Okay, so we've got lots of lns going on here, and we've got no lns in our final answer. So I'm going to combine these lns with my positive, well, my plus and minus rules and my multiplication rules. So if I have something plus something, I know that I then multiply it. Okay, and if I have a negative, I know that I then divide by it. So that's 3 to the power of 2 is going to be 9. That whole thing is in a ln, and that's ln 10. Now I've got one ln on each side, so technically I don't really cancel out, but it means that the inside is also equal. 10. Now I'm just going to actually make that 90. So I'm already multiplying my 9 up. Do I want a 90? It doesn't, oh, I do. Okay, so I want a 90. My bracket 1 plus 2a is also looking good. And can you see, so if I have my 90 divided by 1 plus 2a squared, now I'm just bringing up my brackets, making it a negative power, and then I'm going to cube root. And that is exactly what they asked for. Okay, so that is what goes through my head as I do these questions. Look at what you're aiming for. Just do what they ask. They asked for an integral. They plugged in the boundaries and they told you what it's equal to. So that's all you have to do. You have to integrate, plug in the boundaries, make it equal to ln 10, and then rearrange. All right, now the iterative formula. They're asking for the iterative formula. So we can, this is a nice question. If you ever see one of these, just jump into it. If you can't prove the formula, use it anyway. All right, so they say use the iterative formula based on A to find the value of A correct to 3 significant figures. Use an initial value, so they even give you the initial value, and give the result to 5 significant figures. Each iteration to 5 significant figures. All right, so I will rewrite this. I think it's a good idea just to rewrite it to show what you're doing. 1 plus 2a, and that's just to the power of n, minus 2. And we know our first value is 1.7. And now we've got to go and plug in our second value. Okay, so each of these iterations need to be to 5 significant figures. Okay, you should all be familiar with this, but we're going to plug in our first value. So we're going to plug 1.7 into that A. And if you get your answer, it should be 1.6690. Okay, so that's 5 significant figures. Now you go and you plug in your answer button into there. I think you should all be familiar with that, but if you don't know what I'm talking about, it's worth finding out. It's going to save you a lot of time. Okay, because then you could just push equals, 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 and you can get each iteration. Okay, you don't need to skip spaces like I've been skipping spaces. It's 1.6787. Okay, and then eventually you are to give us to 3 significant figures. So can you see that that is going to round off to 1.68? All right, so that is a really nice question. Make sure that you're comfortable doing these because it's really a good way to get easy marks. All right, let's jump into question 6. Okay, so this is our second last question. Always funny looking things, but the principles remain the same. So let's just see what is this one asking us. They say the diagram shows the curve of that divided by that. Okay, lots of complicated looking things. The curve has a minimum point n. Okay, so first of all, when I see this, I'm thinking quotient rule. It's a function on a function. I'm probably going to have to derive, and I'm going to use my quotient rule. It has a minimum point, so I know dy over dx is equal to 0. And if you were to test it, that would be greater than 0. Okay? But generally, you don't even need the second derivative. I think a lot of my students get confused they go immediately to the second derivative, but you need to remember to find the stationary points. Your derivative is equal to 0. Okay. Okay. It crosses the y-axis at P. Find the exact value of the gradient at P. Okay, where is point P? That is where x is equal to 0. All right, so find the gradient at point P so we can derive and we make x equal to 0. That's going to give us the gradient at point P. Okay, so y is 4e to the 2x plus 9 over e to the x plus 2. Alright, so you need to use your quotient rule. I have put it here on the side. It's this one. Okay, so you just got to puzzle piece this together. You're going to have your v, and then you're going to have your du dx, and you're going to have your u, and you're going to have your dv dx, and all of that is over your v squared. Okay, so if you can work out each one of those, and the first step is to let your top function be equal to u, and your bottom function be equal to v. Right, I just do it automatically. So the way that I do this, a shortcut, is derive the top. So that is going to be 8e to the 2x, and leave the bottom, minus, then you're going to leave the top, and you're going to derive the bottom, so that's just e to the x, and then you are dividing by the bottom squared. Okay, so I didn't use a formula sheet when I did this. So I just puzzle piece it together, but it's exactly the same thing. Okay, so you can either so the way, if you were to use the formula, I would start off with saying let u equal, and then your top formula. So that's 4e to the 2x plus 9, and your v is going to be e to the x plus 2, and then you would derive them each separately. Okay, so that's 8e to the 2x, and this one is just e to the x, and then you've got to literally just paste all the pieces together as they've done in this formula. Right, so now we've got our derivative, and what are we doing? We're going to plug in x is equal to 0. Okay, so I'm not going to write everything down if it's just e to the 0 like that. I'm just going to do that. Minus 4e to the 0 plus 9 times e to the 0. Okay, what is e to the power of 0? Anything to the power of 0 is just 1. So that's going to give us 8 times 3. And that's 13 times 1 over 1 plus 2 is 3 squared. Okay, I just write it all down, rather write down a bit more than less. Oh, sorry, this should be minus over here, not plus. So 24 minus 13, that ends up giving us 11 over 9. And that is our gradient at the point P, 11 over 9. All right. Next question, find the exact coordinates of M. Okay, so we know M is where there's a turning point. It doesn't really matter if it's a minimum or maximum. In this graph, there's only one, but we basically dy dx is equal to 0. Okay, so I'm going to just take this entire part here, and I haven't even simplified it, so it might have been better to do that previously. But it's okay, let's just take this. Okay, I'm going to take my entire function, and I'm now going to make it equal to 0. Okay, so if you can see what's going on here, I've got a numerator and a denominator. It's equal to 0. If I take my denominator and I divide it up and I multiply it up to the other side, it's basically going to be multiplied by 0, so it's going to fall away. So it's my numerator that I need to solve for. So I've got 8e to the 2x minus okay, this is equal to 0. Now, how do we solve this? Such a good question. Yeah, I think the first thing that I'm going to do is I'm going to multiply no. Okay, I think there's different ways to do this. What I'm going to do, what you can see here is you've got two different terms. I've got a term there, and I've got a term there. And they have something in common. They've got an e to the power of x in common. So I'm going to take out an e to the x. This is a little bit of a messy way to do it. So I've got 8e to the x left there. Okay, plus e to the x plus 2. I've also got that. And then here I've just got this bracket. Okay, I hope you saw what I did there. I just took out an e to the power of x. Okay, so now I know that each of these brackets is equal to naught. E to the x is equal to naught, or this whole other bracket is equal to naught. Okay, I'm going to simplify this bracket. Instead of doing it in 2 steps, I'm just going to multiply it out now. This is 8e to the 2x plus 16 e to the x minus 9. That's equal to naught. So I've now got 8e to the 2x minus 4e. Okay, this is starting to look like something that I could solve like a quadratic. Okay, so I've got e to the 2x, and then I've got an x, and I've got a constant. Right, so if I say, maybe a better way to do it, let e to the power of x equal u. So I've now got 4u squared plus 16u minus 9 is equal to 0. And how would we solve this? Let's just see. Is it possible to factorize this? It's not going to work. This looks like it's going to work, so that becomes a positive 18. So 2u plus 9 or 2u minus 1. So u is either equal to minus 9 over 2 or u is equal to a half. Okay, and that basically is the same as saying e to the x is minus 9 over 2 or e to the x is equal to a half. Right, now I always find it handy to know what these graphs look like. So if you take an exponential graph, it looks something like that. So what you can see is this graph is never going to be equal to 0. So if I just take a look up here, this answer is not applicable. There are no answers to that solution. You can also see that it's never equal to 0. The graph never goes below the x-axis. So there's no solutions to that either. And our only solution is e to the x is equal to a half. So if I just ln both sides, I'm going to end up with x is equal to the ln of a half. Right, that is my final answer. I can write this a little bit differently as well. That's going to be to the power of minus 1. I brought up my 2, gave it a negative power, and if you bring the minus 1 down, it's the same as negative ln 2. All right, so let's just see if we answered the question. Find the exact, so we don't want to put that into significant figures, we just want to leave it like that. The exact coordinates of m. All right, so m is only a single point, so when they ask for coordinates, they're wanting the x and y coordinate. Okay, I haven't left myself a lot of space for this. To find the y coordinates, we're going to plug in our x. I'm just copying this down. I'm just going to copy this. Okay, so it might have been better to just space this out in a bit of a better way. Oh, goodness. Okay, let's just rewrite that over here. So y is equal to 4e to the 2x plus 9 over e to the x plus 2. Okay. And we know that our answer is, what are we going to say? Minus ln 2, let's say, for example. So 4e to the 2 times minus ln 2 plus 9 over e to the minus ln 2 plus 2. Okay, and that gives us 4e. Okay, if I multiply my 2 in, it's going to be minus 2. So I'm just going to say 2 to the power of minus 2. Right, I really haven't given myself a lot of space to do this. But 4, my e and my ln kind of cancel each other out. This is going to be 2 to the power of negative 2. This is going to be e. And I'm also going to take up my minus. It's going to be 2 to the power of minus 1. Okay, those e and the ln kind of cancel out. That's going to be a half plus 2. So we're going to end up with 10 over 2.5, which is the same as 5 over 2, which is the same as 10 times 2 over 5. If I cancel out the 2, well, 5 and the 10, I'm going to end up with a 2 times 2, which is equal to 4. Okay, so that wasn't really done very well, but my x-coordinate is minus ln 2, and my y-coordinate is 4. Okay, so just be careful with that and spacing it. I think I would have probably done it a little bit. I should have just, yeah, not wasted space like this, for example, in between each line. Okay, another good idea is to always start on your left-hand side and then kind of write down the line, and then you can always create a second column if you need to. Okay, so that was not a good example on how to space your work, but I hope you got the correct answer there. All right, let's jump right into the last question. So here it says the diagram shows a curve of a parametric equation. Okay, parametric means there's a third parameter, and there's always one formula, y over dt divided by dx over dt. All right, the diagram shows the parametric curve. We've got a k. K is a positive constant. The curve crosses the x-axis at point P, so that's where y is equal to 0. Find the value of cos t at P. Okay, we know that's where y is equal to 0. So I'm just going to use only that. So 0 is 3 sine 2t minus 4 sine t. Okay, so what's the trick? I don't actually know yet. We're going to have to find out. They want to know what is the value of t at P. So I know that at P, y is equal to 0. There's going to be more than one answer where y is equal to 0. So we can expect there to be an answer there and there's an answer there. Okay, so all that I can do is just make my y equal to 0. I've got an equation. There's no cos in this equation, but I do have a sine of a double angle. Okay, so if you go and take a look at your trig, MF19, your sine double angle is over here. So it's going to be equal to 2 sine theta cos theta. All right, so I know that this is equal to 2 sine t cos t, and that whole expression is equal to 0. Okay, if I just multiply out, I'm just going to put my 0 on this side. I prefer it. Okay, so how do we solve this? I can take out, looks like I can take out a 2 sine t, and I'll be left with 3 cos t minus 2. So sine t must be equal to 0, or cos t is equal to 2 over 3. And there we have our answer to what is the value of cos t. It's 2 over 3. Okay, so sometimes the questions are a little bit obscure, but you just need to confidently do what they tell you to do and get your answer. Okay, express the derivative in terms of k and cos t. Right, so what do? We need to find the derivative. We know dy dx is the same as dy over dt divided by dx dt. Okay, once again, I'm wasting a lot of space here, but anyway, it's fine. Y is equal to 3 sine 2t minus 4 sine t. Okay, so if I'm going to just do one at a time. Dy over dt. Now you've got to go and take your derivative. We can see that sine goes to cos. Okay, so I'm going to keep my coefficient. Sine becomes cos. And then I have to multiply everything by the derivative of the inside. Okay, that one also changes. All right, that is my derivative for y. If I now look at x, x is k tan t. Okay, k is just a constant, so my derivative of tan is sec squared x. So dx over dt, I keep my constant, and I now change that to a sec squared t. Right, now if I use my formula, so that's this one over here. So maybe to save space, I didn't need to write down that formula up there. Okay, let's just do it over here. I'm now going to take my dy dt, which is 6 cos 2t minus 4 cos t, and I'm going to divide it by k sec squared t. Alright, so now they wanted this to be in terms of k, and they also wanted it to be in terms of cos t. Alright, so what is sec squared t equal to? You see that I would need to actually bring that up to the top. Well, sec squared theta is 1 over cos theta, and it could be the same way around. Okay, so I'm going to just bring this up. It becomes a cos. So I've got 6 cos 2t minus 4 cos t. That whole thing is multiplied by cos squared t, and everything is divided by k. And that should be the correct final answer. It might look a little bit different. It depends if you multiply in the cos squared t or not. But the idea is that. Okay. And, oh, hold on. They said in terms of cos t. They didn't say in terms of cos 2t. Right? So we actually need to change our cos 2t into something else. And I'm just going to go grab my MF19. So my cos 2t, this one over here, we can change it to 2 cos squared t minus 1. So that is important to change. Okay, this becomes 2 cos squared t minus 1. This whole thing is multiplied by cos squared t, and it's over k. I am just going to simplify this for the sake of make sure we have the right answer. Although I think this is what the mark scheme gives us, something like that. Okay, but it could be presented in a couple of different ways. That is the answer to that question. Once again, don't write the formula up here. Start on the left-hand side. You won't have a sheet on that hand side, so you would probably have then set up a second column on the right-hand side. Okay, so just practice just before your exam. Make sure you're not working on an iPad. Make sure that you're working on real paper, so you can practice your spacing. You can practice, if you make a mistake, you can't just erase it. You have to leave it there. So make sure that you do enough papers on hard copy paper. It sounds funny, but the friction of a real pen is very different from the friction of your iPad pen. Okay, so make sure to be practicing. Now, they say, given that the normal of the curve P, so the normal to the curve at P, okay, so the normal to the curve at P. So if we take P, we know you'll have a tangent, like something like this, and you will have a normal. And the gradient of this one is 9/10. Okay, so that means the gradient of the tangent is minus 10/9. Okay, but we don't know what they're actually asking us. Given that the normal to the curve is that gradient, find the value of k, giving your answer as an exact fraction. All right, so let's just figure this out. What has that got to do with k? So we worked out the derivative. Okay. If we also know that p cos t at p is 2/3. Okay, so we've got our derivative, uy dx, where x is equal to p. We know that cos t is 2/3. I think that's going to be useful information. Okay, so I can literally, this is my derivative over here. I can take my derivative and I can plug 2/3 into all my cos t's. I think that would be valid. Okay, so 6 times 2, and then this is a 2/3 squared minus 1. Squared minus 4 times 2/3 to the power of 3, and all of that is divided by k. Given that the normal to the curve, okay, so this is at p, we know that the gradient at p is minus 10/9. Okay, so it's the inverse and negative of the normal. Find the value of k as an exact fraction. Okay, so the only thing that we don't know now is the value of k, so we can solve for k. Right, so super interesting way of asking a question. All the principles are the same. Nothing is new in terms of principles. So you just have to strengthen your principles, I guess. Okay, I'm going to 10/9. I'm just going to multiply my k onto that side because there's a lot going on here. Okay, if we simplify this, 8/9 minus 1. Okay, you can do all of this on your calculator. I actually don't have a calculator with me. Okay, so minus 24/81. Okay, these can be simplified. and your answer should be 4/3. Okay, so just double check that you do get to that answer. Sorry, it took me a bit of time. But yeah, your k should then be equal to 4/3. So can you see how we use part A and part B in order to solve this? So I always want you to just be aware and looking out for the questions before, especially if it's a ABC part question. Always check, how does this relate to what I'm doing? And then all the principles remain the same here. It's just the math does get a bit interesting, but the principles are not changing for each and every one of these questions. So you need to make sure that you're really comfortable with the general principles of what is differentiation, what is a normal, what is a curve. All right, so that concludes this paper. I hope that that was helpful for you. Yeah, that's all for today.